Assalamu alaikum, dear students. I'm back with the new chapter. I hope you all are doing well and enjoying your summer vacations. But as I told you earlier, study is also important alongside. That is why I am back with another chapter, chapter number 6 of your science book. And this chapter tells us about air and the atmosphere. As the previous chapter, this chapter is also in the two parts. In this video, we will discuss the first part of the chapter, and in another video, we will discuss the second part of the chapter. Here is a beautiful picture of the atmosphere with the beautiful colors with its different layers. Now we will proceed to the definition of the atmosphere. Our Earth is surrounded by a thick layer of air called atmosphere. The atmosphere prevents the Earth from being too cold or too hot. It supports life and also causes changes in the weather. This is a beautiful picture of the atmosphere or the air, basically. The function of atmosphere is to prevent the earth from becoming too cold or too hot or too cold. The composition of air. Basically, the thick layer of air we are calling as atmosphere. That is why now we will learn the composition of that thick layer of the air. Basically, air is mixture of gases with oxygen and nitrogen forming the largest parts. As we have to, as I have told you earlier about the pie chart, that the pie chart is a circular chart that divides the all the components according to their percentages. Here is also a pie chart about the composition of the air. In this, the 78% of a pie chart is carried out by the is carried out by the gas, that is nitrogen. The second most abundant gas in the atmosphere is the oxygen. The third abundant gas in the atmosphere is the argon, and fourth one is the other gases that are present in the different amounts, and the carbon dioxide is present as a 0.03%. So you have to learn these percentages of the different components of the atmosphere. The largest component of the atmosphere is the nitrogen with the 78%. The second abundant is the oxygen with the 21%. 20.9% is equal to the 21%. Argon with the 0.9%. Carbon dioxide with the 0.03%. And along with, there is also some percentage. There is a minute percentage of the water vapors along all these gases present in the air. And that amount of the water vapor in the air is called humidity. Air is soluble in water. Now this is interesting concept. Air is soluble in the water. If you heat some water in glass pot or beaker, you can see this water coming off as bubble. Here is a picture of the water taken in a glass pot and heated by a gas oven. In this, we can see that when the water starts boiling, after a lot of heating, it forms bubbles at its surface also. All these bubbles are basically because of that air that is dissolved in the water. That is why we say that air is soluble in the water. Now, how much amount of the air is soluble? At room temperature, every 100 cubic centimeter of water contains about 2 cubic centimeter of the dissolved air. This is basically the amount of the air that is dissolved in the specific amount of the water. Important processes that uses air. Air is important in a number of natural and industrial processes, and that list starts from the respiration and goes to rusting, photosynthesis, combustion, and the manufacturing of oxygen, nitrogen, and argon. Among all these processes, we will discuss respiration, rusting, photosynthesis, and combustion in detail. So first is the respiration. Respiration is a process by which living things break down food and obtain the energy they need to grow and live. You have learned about the respiration in the previous chapters, but I am explaining it to you again to remind all the concepts in your mind. Respiration is basically a a process by which living organisms find their energy. For example, if we talk about a plant, this plant takes or consumes oxygen, and it also consumes glucose. It consumes two ingredients, oxygen and glucose, and it gives out two products. One is the carbon dioxide and other is the water. Um, this concept that I am telling you theoretically is written here in the form of the equation, and you have to learn this equation of the respiration, in which we are stating that for the process of respiration, glucose plus oxygens it's not oxygens, it's oxygen. Glucose plus oxygen are the reactants, and carbon dioxide and water are the products. Second process that uses oxygen is a rusting. Rusting is a chemical reaction between oxygen in the air and air. So this is basically rusting is basically a chemical reaction between oxygen and iron in the presence of the air, and there is another factor that requires for the process of the rusting is the water. Water is also required for this process, and rust is basically a form of iron oxide. This is so important, and you have to learn this. Rust is a form of iron oxide. All these theoretical points, I want to clear this out in your mind. That is why I have added a beautiful picture of process of the rusting. Here is a clean, shiny pair of scissors. This is basically made up of iron. As we have stated here, that rusting process includes the reaction between oxygen and iron in the presence of the air along with the water. So all these ingredients must be there for the process of rusting. So that is why there is a scissors, a pair of scissors basically, that is made up of the iron, first ingredient. Second is the iron react with the oxygen in the presence of the water. This oxygen comes from the air, so that component goes here in the presence of the water. So the process of rusting takes place. Iron and oxygen react together and form iron oxide, that is basically rust, and the beautiful shiny silvery pair of scissors converts to this rusty scissor, because there was a process of rusting, and that is the reaction between the iron and oxygen. As there is oxygen and this oxygen comes from the air, that is why we state that rusting is a process that uses or utilizes air. The third process that uses air is the photosynthesis, and you have learned photosynthesis many times before. Photosynthesis is a process used by the plants to convert carbon dioxide gas and water into glucose using sunlight energy and chlorophyll. Oxygen is released into the air as a waste product of this process, and this waste product of the photosynthesis by the plants is basically the main vital component for the survival of the life. We human beings and animals also utilizes this oxygen for the respiration. Now, as we are saying that the photosynthesis is a process that utilizes carbon dioxide and water in the presence of the sunlight, that utilizes carbon dioxide and water in the presence of sunlight and chlorophyll to convert these ingredients into the glucose, the energy that uses by the plants, plus oxygen. Where do these ingredients come from? First of all is the carbon dioxide. Carbon dioxide is absorbed by the leaves of the plants. Water is absorbed by the soil, from the soil by the roots of the plants, and this sunlight is absorbed by chlorophyll. These two ingredients that are written above and below the arrow basically, and sunlight is being absorbed by the chlorophyll. Where the cursor is gone. Sunlight is absorbed by the chlorophyll, and all these ingredients mix together to form glucose and oxygen, and all this all this process together is known as photosynthesis, and it utilizes air for its process to be completed. Here is a beautiful picture of the process called photosynthesis, and this picture will clear out the things in your mind. Because in the photosynthesis we have learned that the plants use sunlight and carbon dioxide and water. Then all these three things are being processed by the chlorophyll, that is a green pigment in the plant, and it converts, and the chlorophyll converts all these things to the products, that is oxygen and sugar. Sugar and glucose are equivalent, so don't get confused, dear students. Products are oxygen and glucose. This glucose is being used by the plants itself as an energy, and oxygen is a waste product, and this oxygen is basically utilized by the animals and the human beings to for the breathing basically. Now there is a comparison between the photosynthesis and the respiration. Photosynthesis is basically the process that is carried out in the daytime by the plants and the trees, and the respiration or the cellular respiration is basically the process that is carried out by the trees and the plants in the night time. Now in the photosynthesis, light energy is being absorbed and the carbon dioxide is being absorbed by the tree, and the product is oxygen. Carbon dioxide is the reactant. Carbon dioxide is being absorbed and oxygen is released by the plant. In the case of respiration, oxygen is being absorbed by the plant and carbon dioxide is being released by the plants. Hence, you can see, dear students, that photosynthesis and respiration are basically exact opposite to each other. In the photosynthesis, carbon dioxide is being absorbed. In the case of respiration, carbon dioxide is being released. In the case of photosynthesis, oxygen is released, but in the case of respiration, oxygen is being absorbed by the plants. So basically, these are the two processes that are carried out by the plants in the daytime and in the night time. Now, there is another process that utilizes air, that is called combustion, and combustion means burning. There was a French chemist, Lavoisier, who showed that substances use oxygen for the air when they burn. And the examples of burning are candle or a piece of charcoal are the examples of the combustion. Combustion usually produce carbon dioxide and water and release a lot of energy. Here is a picture of the process of combustion where woods piece of woods are basically burning, undergo the combustion. Here this picture clears out that oxygen is basically being used in the process of the combustion, and water and carbon dioxide is being released during the process of the combustion. Here is an example, here is an equation of the combustion of the methane. Methane plus oxygen, it converts to the carbon dioxide. As we have told, carbon dioxide and water are produced in the process of combustion, plus a lot of amount of energy is released. This delta H is basically that amount of energy. Is being showed by the delta H in this equation. So this is basically the process of combustion, and you have to learn the equation of the burning process of the methane. Basically, when methane burns, carbon dioxide and water are produced, and the equation looks like this. Here completes the list of the processes that utilizes air. The first process that utilizes air was the respiration. Second process was the resting. Third process was the photosynthesis, and the final process was the combustion. So here the first part of the chapter completes. The second part of the chapter will hold all the remaining topics of this chapter. So I would like to take leave here. Take care of you, dear students. Take care of your parents. Take care of your siblings. Take care of your environment and keep your environment clean. Keep smiling. Allah Hafiz.